In this video, we will derive the double angle identities for sine and cosine. Take note that the double angle for cosine has three different forms, and we'll discuss all three. The double angle formula for sine comes from the sine sum formula. Sine of a plus b equals sine a cosine b plus cosine a sine b. So to make use of that formula, we're going to treat the double angle for sine of 2x, as sine of x plus x by addition. Now we can make use of the addition formula above by replacing a with x and b with x. And we can call this form sine x cosine x plus cosine x sine x. And we have two sine x cosine x terms, so we can add them together and call it 2 sine x cosine x. So what we have is that the double angle for sine of 2x is equal to 2 sine x cosine x. So here we have the double angle for cosine. We're going to use the cosine sum formula shown up top as well. Substituting a with x and b with x, we can treat this as cosine of x plus x. And then with a substitution here, using that sum identity up top, we can rewrite this as cosine x times cosine x minus sine x times sine x. And then by multiplication, we have cosine times cosine is cosine squared x, minus sine times sine is sine squared. So the first version for the double angle for cosine of 2x is equal to cosine squared x minus sine squared x. And now to derive the other two forms. The other two forms come from the Pythagorean identity. Let's write this out as sine squared x plus cosine squared x equals 1. Whenever you have sine squared plus cosine squared, that's always equal to 1 in trigonometry. So to make use of a substitution step, I want to use the Pythagorean identity for cosine squared. So if we solve for cosine squared on the Pythagorean identity, we can do that by subtracting sine squared on each side. Cosine squared x will be equal to 1 minus sine squared x. So I'm going to substitute now into the result that we have for cosine squared minus sine squared, and I'm going to substitute in place of cosine squared x, we can write 1 minus sine squared by the Pythagorean identity. And then maintaining the minus sine squared x, you can see from the second form that we're establishing here, 1 minus sine squared is equivalent to 1 minus 2 sine squared x. So here's the next form for our double angle for cosine. Cosine of 2x is also equal to 1 minus 2 sine squared x. That's if we want to have that double angle completely in terms of sine. There's another form that we could do to turn this completely into cosine. So I'm looking at the first step of our Pythagorean identity in purple over here. If we isolated sine squared x by subtracting cosine squared to the other side from 1, rewriting it as 1 minus cosine squared x, we can substitute that in place of sine squared x, deriving from the Pythagorean identity. So, taking a look at what we have here, as the second result, I can substitute sine squared x with 1 minus cosine squared x, distributing the 2, distributing negative 2. Technically, negative 2 times negative cosine squared x is positive 2 cosine squared x. This leaves us with a positive 2 cosine squared x, which we can write in the front. And the positive 1 and the negative 2 make a negative 1. So here's the final version for the double angle for cosine when you want to rewrite cosine 2x as 2 cosine squared x minus 1 completely in terms of cosine.